Welcome to Click My Project. Now we are going to discuss about title of our project. Our project title is Forced and Probably Accurate Bilateral Filtering. Now we are going to discuss about the abstract of our project. The bilateral filter is a nonlinear filter that uses a range filter along with a spatial filter to perform edge preserving smoothing of images. A direct computation of the bilateral filter requires of S operations per pixel, where S is the size of the support of the spatial filter. In this process, we present a fast and probably accurate algorithm for approximating the bilateral filter when a range of kernel is Gaussian. In particular, for box and Gaussian spatial filters, the proposed algorithm can cut down the complexity to O of 1 per pixel for any arbitrary S. The algorithm has a simple implementation involving n plus 1 spatial filtering, where n is the approximation order. We give a detailed analysis of the filtering accuracy that can be achieved by the proposed approximation in relation to the target bilateral filter. This allows us to estimating the order n required to obtaining a given accuracy. We also presented comprehensive numerical result to demonstrate that the proposed algorithm is competitive with the state-of-the-art method in terms of speed and accuracy. Now we are going to discuss about the flow diagram of our project. First is an image acquisition. So image acquisition is the first stage of any vision system is the image acquisition stage. Image acquisition is the digitalization and storage of an image. After the image has been obtained, various methods of pre-processing can be applied to the images to performing the many different vision takes required today. First, capturing the input images from the source file by using UI get file and imRead function. Using can be able to change the size of the image by providing the pixel height and width with the help of imResize function. Then add a noise. Additive white Gaussian noise AWGN is added to the input image and uniformly to all the pixels of all the input image. Gaussian distribution function is employed for generating the unwanted pixels information to the images. The generating the Gaussian distribution values when added uniformly over the complete image. The noisy images is represented using the following formula: y equal to x plus c. Next, we are going to apply for filtering. Here, the first bilateral filter is applied to two methods. One is the Gaussian bilateral filter, another is a box bilateral filter. The proposed forced algorithm for computing which the motivated by the lines of work, in particular similar to these papers, we presented a novel approximation for that allows us to decompose the bilateral filter into a series of spatial convolutions. The fundamental difference between the above methods and the presenting approximation is instead of approximating then translating the approximation in the range space, we directly approximated the translated Gaussian appearance. In particular, the computational advantages obtained using the proposed filtering methods for a fixed approximation order to be defined shortly. The proposed approximation requires half the number of spatial filters. The proposed approximation does not involving the transcendental function cos of omega x and sin omega of x, which are used in some existing methods. It only involving the polynomial and just a single Gaussian and hence can be exactly implemented on a software and hardware. Moreover, a rounding error is small when working on polynomial. Finally, we filtering the noise means then we go to the performance measures. The performance measures of the enhancement process is measured based on the PSNR and the FSIM calculation. The calculated performance metrics indicates that the proposed method is more efficient and comparing to the existing method. Now we are going to discuss about the output of our project. The title is Fast and Provably Accurate Bilateral Filtering. Now in this project the coding is implemented in MATLAB or 2013A version. Go to the current folder and selected a main.m file. The main.m file is the main file. So selected a run button. Now run the project. Now I am going to selected a 5.jpg image. Now run the project. First one is an input image. The input images is displayed here. Then pre-processing is applied here. The pre-processing step is one is an resized image. The given width and height is applied to resize the image using im resize function. Next one is an RGB to gray conversion. Gray images is displayed here. Next one is a Gaussian bilateral filter is applied for gray image. The Gaussian bilateral filter is applied here. The input images is compared to the Gaussian bilateral filter. Here the noises is removed and displayed the output panel. Finally, box bilateral filtering is applied here. So input and Gaussian bilateral filter PSNR value is 38.6254 and Gaussian bilateral filter FSIM value is 0.96633. Input and the box filter PSNR value is 36.7557. Box bilateral filter FSM value is 1.0786. Thank you for listening. Our demo is completed. Thank you.